Welcome to the webinar podcast series. Really excited to have a old friend of EBA, Joe Nebbia, with us today. And today we'll be talking about cost-effective strategies for achieving zero energy homes. As usual, we'll have a Q&A section. Put your questions in the Q&A. You can chat them as well. I'll be monitoring that throughout and posing those questions to Joe as he goes through. We'll hold a little bit of time at the end for additional questions. If you want to watch this in review or share it with someone after, it'll be up at eba.org in the Academy, as well as on our Better Homes, Better Future podcast series, which you can download on your favorite podcast. Joe, I always say I'm no Joe Rogan. I also say I'm no Joe Nebbia, and I'm always so pleased to get to spend some time with you, Joe. I don't know if anyone in the country knows the building code, especially as it relates to high performance better than you. So I'm just extremely pleased to get a chance to spend an hour with you here today. So Joe, with that, I will turn it over to you.
Well, thank you, Aaron, for that very kind introduction, and I just echo your thoughts that it's great to have this long-term partnership with EBA, and can't think of another organization that better exemplifies the goals we all have in trying to push high performance zero energy building out into the market. So thank you again for having me on. It's always a pleasure. Today, we're going to talk about cost-effective strategies for achieving zero. As Aaron mentioned, he's going to ask questions throughout, so please submit those questions as I talk, and I'm happy to get to as many of them as we can. Pretty tight time frame, an hour to talk about any topic, so I may try to move on if we're getting stuck with too many questions. Another thing I'll stress about this class is it's impossible for me to tell you how to design your specific home cost effectively in an hour. So just a little disclaimer there that if you're hoping that I'm going to give you the answer for your specific house and your specific market and supplier conditions, I don't think that's really possible in this type of a talk, but I'm going to talk about concepts that I think apply to how we go about achieving zero cost effectively. So the first thing that I think is important for us to ask when we talk about how to get to zero cost effectively is, what is zero energy and how do we define it? Because defining that really is important to setting a bound around what we're considering cost effective. So that's very important that we all start with, at least from a discussion point of view, the same definition. And I don't mean whether you're net positive or actual zero or HER zero or ERI zero. That's not really what I mean. What I mean is what has to go into every zero energy home for us to consider it zero energy. And I think as we talk about this, you'll see what I mean when I say that including these things is going to change the discussion a little bit about what's cost effective. So obviously efficiency is a big part of zero energy home. We have to get the home as efficient as possible so that we're not wasting any energy, even if it's generated with renewable energy. And then we have to add on generation, and that can look like a lot of different things. That could be rooftop solar or something like that. It could be a power purchase agreement or community solar. It could be some other kind of situation where we're generating energy that we haven't thought of yet. And there are a lot of policy implications around when we count those and when we don't, for say code compliance or program certifications or those sorts of things. But generation can look like a whole lot of things. And then we have to have storage for an effective zero energy home. We have to be able to use battery storage to maximize that solar or other generation and to maximize the potential of a zero energy home, which is to be independent from things like grid outages and issues like that. And then we have to have in a zero energy ready home, and I'll stress this, comprehensive indoor air quality and moisture protection, because it doesn't do us any good to build an incredible home that uses no energy that doesn't provide good indoor air quality, that has problems with mold and breathing issues, and ends up being problematic for the customer at the end, that's going to be lawsuits, that's going to be health problems, and we can't define that as cost effective in any way. So we have to have comprehensive indoor air quality and moisture protection. And then finally, we have to build in durability and quality so that we lock in that cost effectiveness and are able to realize it over the longer term. So when I say a zero energy home, it includes all 5 of these components. And that's how I'll be addressing it in the class today. So what makes up a zero energy home? Zero energy home, what are the parts? First, we have to have an advanced envelope, and I'm going to go through these a little less detailed than I would in, say, a 2-hour class, but we have to have a fully insulated and air sealed envelope. We have to have advanced heating and cooling so that we're conditioning the space efficiently. We have to have advanced water heating so that we're delivering hot water in the most efficient and comfortable way possible. And then we have to have efficient components like lighting, appliances, controls, and those sorts of things. For water management and indoor air quality, we have to manage both the bulk moisture and also make sure we're controlling vapor flow and things like that correctly. So we have to keep the water where it's supposed to be. We have to manage indoor air quality through comprehensive ventilation and filtration, possibly dehumidification and controlling pollutant sources. And then I've got an extra thing on water heating there, so we don't have to talk about that one. For actually getting to zero, then we need to first start with the right sized home, right? So the bigger our house is going to be, we can still get it to zero. You know, there's a lot of discussion about, can a really big house be green? We can get that to zero, but it's going to take a lot more generation to get there. So we want to right size the home so that we know we can meet that zero energy target. We want to generate using a lot of the options I've already mentioned. And then we want battery storage, and that's going to give us not only ways to improve the efficiency of our generation system, but also grid resilience and possibly improved EV function. So those are the components I'm thinking of when I say zero energy home in detail. Next, I'm going to talk about how do we define what's cost effective for zero? There are a lot of considerations for that. So first, cost is important, right? It's not the only thing, but it is a thing. And it's a lot of times when we talk about how to make zero energy cost effective, this is what we're thinking about, how to make the first cost effective. I think many of us in this space also talk about things like operating costs and things like that. But I also want to talk, as we get into this, about concepts like first savings and cost versus value. There are things about first costs that change with the learning curve, and we need to consider that. How many of our first costs are one-time design costs that are going to change when we repeat the design? Then we talk about buyer operating costs. That's going to be important to the home buyer or the occupant. Builder operating costs, things like warranty issues and reduced callbacks, fewer days on market. These are things we have to consider in designing the zero. These are some of the benefits. And then we need to think about other benefits outside of energy, things like savings from having healthy indoor air, health benefits, and the cost savings of having resilient, durable, quality design. So the first concept I want to address here is cost versus value. And I would say that we often in the building industry, we fail to give our customers a good experience with our product. And we only have one shot at it usually. We don't get a lot of repeat customers in the building industry. Depending on the builder model, maybe you do. But we fail to give that customer a good experience with our product. And a big part of that is we bring all of the cost, but none of the value. And so an example of that is insulation installation. We can talk about how much does getting to zero cost from an amount of insulation point of view. But in the picture here, in the top left of the screen, you'll see some significant compressed insulation. It's an R21 bat. It's a friction fit bat. It's installed in the cavity there, and you can see that they didn't do a very good job installing it. They've actually put way too much insulation. They didn't cut it to fit the height of that cavity, and they've just kind of stuffed it in there. And so what I think this exemplifies is that it's not costing the builder less to do it this way. Not really. They're buying the same amount of insulation. And so when you're designing a home and speccing out the envelope package, your buyer is paying for that amount of insulation. But in this case, they're getting maybe 50% of the value because it's not going to perform when it's compressed like that. And so realizing that we need to deliver value when we're asking our home buyer to pay for something is an important part about making this cost effective, right? They're going to pay for something, they have to get the value out of it. Same thing on the picture on the right, we see fiberglass insulation stuffed around the window for the install. This is a renovation project here where they're doing some window replacements. And like most window replacements we see, they've stuffed insulation around the windows. Here's a situation where there's no value being added for the customer. That needed to be caulked or foamed. The fiberglass isn't doing anything because it's been compressed and it's air permeable. So it's not air sealing anything or insulating anything, but somebody had to take all the labor time to sit there and cut little strips of insulation and shove it around the windows. And that's something the homeowner's paying for here in this renovation. So again, cost is added with no value. So central theme here, anytime we're adding costs, we need to give value to the homeowner. Same thing, picture on the left here, we have a duct that we've got too much length of duct. And I added a flex duct picture here because there was a time when we couldn't get flex duct a year or so ago. It was this rare commodity, and we would want to maximize our flex duct length as much as possible, or minimize, excuse me, because the material was hard to get. And here we've got an extra 2 feet of bend there that didn't need to be there. It's actually providing a worse CFM in the install, and we've had to use more material. And then finally on the right, you see a picture of slab edge insulation that's doing nothing. Because it's not creating a thermal break at the slab edge. So somebody took the time to buy that material and install it, and it's providing the homeowner with no benefit. So again, if we're making the homeowner pay for something, we want to provide that value as it's coming in. The next concept I want to discuss is products with multiple benefits. And I think there's no one answer with any of this. You have to think about whether these products fit your type of building and your market, your supplier base, that sort of thing. But anytime I can, I'm looking for ways to get a product that's going to meet multiple goals for me. So again, this is conceptual. This might not be the right product for you, but here's an example. Here's a zip product which has an insulating factor to it. It's also so it's creating a thermal break as continuous insulation. It's a structural in nature, so it's providing your structural sheathing, and with the tape, it's also providing your air barrier. So I'm getting one product or one system really that's providing my structural, my continuous insulation, and also my air barrier. And I want to think about anytime I can pick a product that does multiple things for me like that. Another example, this is a picture of closed cell spray foam, but spray foam again does multiple things. It insulates, it air seals, and in some applications it can provide structural benefit as well. So that's an example of a quality that other insulation products might not have. Not saying spray foam's the answer for everybody, but that's an example of a product with multiple benefits. Here's an example of a balanced ventilation system with recovery. I'm not sure if it's an H or an ERV. I can't look quite that closely, but the point here is not that this is the cheaper system necessarily, but when we're designing things, we need to think about where we're pulling our exhaust air from and think how we can offset some of that cost by doing multiple jobs. So one common design is that you're going to see bath fan exhaust feeding into the H or ERV. That's sort of a common balanced ventilation approach where you're pulling air from the bath because you need to do that anyway, and that's part of your H and ERV design. So you're taking advantage of this system that's more expensive, but you're eliminating other fans that you might need. So think about those benefits where you can get them. Getting past the learning curve I mentioned early on. This is true about a lot of products where when we start to incorporate a change into how we're building something, there can be a big upfront cost. And if we're moving ducts from the attic to in-conditioned space, there's a redesign cost, right? We've got to change our floor plan. If we're maybe using heat pump water heaters for the first time, our utility closet might need to be redesigned from what we were using before. Those are important costs to consider, but they're not ongoing costs in that once we've got them designed into our systems, we don't pay that learning curve cost again. One example is advanced framing. In that case, we're actually going to reduce the total framing cost going forward. But there is some learning curve cost for our trades, the carpenters, to understand how to implement that. So there's going to be upfront costs, but hopefully it's a saver over time. And then next we have an example of a structured plumbing with a recirculation loop. Again, this is if I'm trying to do recirculation for hot water comfort and water efficiency, there's going to be an initial plumbing redesign. This isn't how we would typically plumb a house if we're not using this recirc system. But once you've got past that learning curve, once your plumber has it standardized in their design for your homes, then we can start to lower that cost of that technology a little bit. Next, I'd like to talk about how we view costs in material versus installation. And there's choices here. Again, like the products with multiple benefits, I'll say there's no one approach here to what's going to work for you, but you have to think about, do I want to save money on my materials or do I want to save money on installation? And those aren't always in conflict either. But different products are going to have different capabilities that you need to think about. So, here's an example of double wall here on the left, and this builder, good friend of mine, who's often said they knew how to build a 2x4 wall, so they just had their carpenters build 2 of them, and now they've got a double wall with a thermal break in between, and it's a super insulated wall. They could have invested in a very innovative super insulating wall product. Instead, they built a very simple wall. Built it twice and filled it with blown-in insulation. So the actual construction is simple in that case, but the end result is very high performance. So it's not always about picking the most innovative, advanced system. One thing I'll say about this is if you're in the humid climates versus the dry climates where this is, you need to be a little bit careful about your moisture design. On the right, it's hard to see in this picture, but it's a similar concept. It's a staggered stud wall. That's when they've got a 2x6 top and bottom plate with 2x4 studs that are staggered to the front and back of the bottom and top plate, so that you've kind of got a weaving continuous insulation situation. And then they've added some additional zip system to the outside. But the point of this concept is you have to decide as a builder what's going to work best for you. But it may be that a simple design done really well or done with extra amounts of insulation can perform as well as something more complex. Here's another example of that where we've got a builder that's using caulk and a liquid applied gasket. Very simple products. They're not expensive. They're low cost products that can be applied with attention to detail and achieve really good air sealing. So in this case, again, they're buying cheap materials. Caulk is not expensive, and they're applying it in a way that is focusing on high leakage areas and achieving really tight construction. An opposite approach might be, we could spray foam things instead of doing caulks. And that's going to be more expensive, but we might like the application better. Or as shown here on the right, that's an aerosolized air sealant. Again, that's a totally different process, really innovative, cutting edge, and it's all about the process. We're going to invest in the process and less in the material and more in the material, but maybe we have to pay less attention to the detail than we would in caulking the exact right joints, because this is going to fill everything. There's also a repeatability of design there that's really important. If I can get to the same blower door test result on every one of my houses because this product is going to do that for me, there's a cost effectiveness to that. Now it's important for us to also consider what cost considerations are important to the buyer. So when we're building or designing a zero energy home, we want to know about first costs, right? What can we afford to actually build and then get value out of in the sale? But for buyer costs, that's a completely different factor, right? First cost is still important because it's going to mean higher home price and higher mortgage payments, but our operating costs may be lower. So we have a net monthly cash flow that's positive. That's not a concept that's probably a surprise to many of you, right? So first cost is only part of that equation when it comes to the buyer. We know that when we have better quality, we're going to have fewer repairs, lower maintenance costs, and fewer long-term durability issues. That's something that many home buyers would be willing to invest in. I have a quote here from Builder Online that talks about common construction defects in just about everything that we build: weather barriers, framing, mechanical systems, plumbing, fire-resistant assemblies, window and door installations. We have a high defect industry. Not saying people on this call are necessarily in that camp, but that is an industry that we work in. And there's lower costs for our buyers if we can limit those defects. And again, one of the building blocks of a zero energy home is quality and durability, at least in my definition. Opportunity cost. How many times do we get to build a home the first time? It's just once. We have the opportunity to do it right the first time, and there's certain parts of that we need to realize for the consumer so that they don't have to go back and change things long term. Building cavity ducts, that's a poor opportunity cost choice. Maybe cheap for us to cut a hole in a drywall cavity and a stud cavity and call it a duct, but it's not going to give good airflow, and it's going to be bad indoor air quality, and we're going to have moisture problems in that space, and it's leaky, and it's impossible to inspect and seal correctly. So we've now given that homeowner a really bad duct system for the rest of their home's life. Ducts in conditioned space, right? We want to keep our ducts out of the attic. We don't want to pass our glass of ice cold water through the oven before drinking it. And designing our ducts in conditioned space is one of those opportunity cost things where the homeowner's not going to be able to do it later. The picture in the middle there is kind of funny, right? You imagine drinking through a straw like this. Obviously, that's a pretty extreme example of bad duct installation, but it's something that now is going to be very hard to fix for the homeowner. And then I talked before about slab edge insulation. We're never replacing that slab edge insulation, at least in most installations. Getting that right the first time is absolutely crucial. Another concept that I often think about with insulation is more insulation the best path? The answer is probably yes, right? We want more insulation. That's probably going to get us where we want. to go. However, there is a situation that I'd like you to consider that will have a cost impact, and that is the amount of windows we put in these homes. This is not my data. It's something from Journal of Light Construction, and it's a calculation. It's pretty simple, but you see here, if I have a U value of 0.30 window, that's code in climate zones 3 to 8 now for 2021 IECC. But I've got a R39 wall. That's a pretty big double wall, pretty significant. If I have just 15% window to wall area, my R39 wall is really an R15 wall from a whole assembly point of view. If I have an R60 wall, which is insane, right? It's only R17 if I've got a 0.30 window. And even if I get really down into some incredibly low U values on my windows, 0.15 is an insanely good triple pane window. At that R39 double wall, I've still only achieved an R23 at 15% window to wall area. What's the message here? Fewer windows. So nothing against windows. We need them. They're great. They let light in. We can open some of them and let air in, not mechanical ventilation, but it does allow us to do that. It gives us egress. There's purposes to windows, and I'm not saying to get rid of them, but we could do with fewer of them. And they're more expensive than just having a blank wall with insulation in it. We can get to zero much more cost effectively with fewer windows. Eliminate windows, we lower our envelope costs, and we're going to make that wall perform that much better in reality. Now I'd like to talk a little bit about resilience, and that might be disaster resilience. It could also be thermal resilience in keeping our heat in when the power's off. It can be grid resilience so that when the power goes out, we can keep powering things, or even just optimizing our generation system so that when the sun's down, we're using the battery instead of the solar system, which wouldn't be an option then, and we can make our zero energy performance even better. So again, thermal resilience, I talked about that. If we can have a home that only drifts 1 or 2 degrees after a few days of no power in upstate New York or Minnesota or North Dakota, that's a pretty amazing thing, right? Power resilience, if the power goes out and I can still keep operating my house, that's pretty amazing. And then finally, disaster resistance. If we're going to build a zero energy ready home, I don't want it to blow away. I don't want it to blow down. I don't want it to fall down during an earthquake. Wildfire, I'm not sure we have really come up with the best way to prevent homes from burning down in wildfires. We have some strategies, but if a wildfire hits your house, it's not a ton you can do, right? For wildfire pollution resilience, if there's a wildfire in the area, we want to have high capture filtration and things like that so that people can still breathe and stay in their home. That zero energy home, excuse me, is going to be that much better and cost effective if we don't have to replace it or repair it significantly during after a disaster. Think about how much smoke damage costs in a home. If we can keep that smoke out during a wildfire event through filtration and ventilation controls, we've now saved that customer a whole lot of money. Along the lines of resilience, accessibility, and adaptability, again, a home that we stay in will be more cost effective than one that we sell and move and move and move. So if we can design adaptability, universal design to our homes, that zero energy home is going to be able to pay for itself because we're going to be able to stay in it longer. Now that I've talked about those concepts, I want to talk about specific case studies where people are implementing a lot of these strategies around the country. Most of these case studies are from award-winning builders. They're on the Department of Energy's Tour of Zero, and you can look at them in more detail there, but I want to talk about some and highlight each of them. We've got about 30 minutes left in the class.
Joe, why is there no driveway on that house?
Yeah, I think it's over on the left there. right? No, not all homes have a driveway.
There's a
Oh,
garage
right.
door.
There's a garage, right?
There's a
Yeah,
garage door right in the
yeah.
front.
That's funny. No, I've never
Sorry.
noticed that about that picture.
Sorry. Just a reminder, put your
Yeah.
questions in the Q&A. We'll keep asking to Joe. I do see there's something came up in the chat. I think it's just a thumbs up for the case studies. So
Yeah. And by
let's
the
drive
way,
on.
I'd love to see a off-road EV that would work well with this garage. I guess you would need it in that case. I think the plants in front of the garage are a nice touch too.
Absolutely. All right, no questions thus far. Thanks.
Okay, so the first home I want to uh, talk about is this. It's a Habitat home in Connecticut. Obviously, part of Habitat's mission is making things affordable. I'm not saying, everything about cost-effective design has to be about a specific affordable housing program or things like that. And cost-effective can be in different ranges, right, for different buyers. But this is an example of an affordable home that reached PERS -7, which is pretty impressive. They used a open cell spray foam in the cavity as well as continuous sheathing and advanced framing to get to an R31, R60 attic with blown-in insulation, R21 basement with a precast basement system, triple pane windows, and a very tight 1.12 ACH 50 using their spray foaming and zip wall as their air sealing strategy. For mechanicals, they used ductless mini splits and transfer fans to move that heated and cooled air throughout the house. They had a heat pump water heater as well as an energy recovery ventilator. And, LED lighting is not really innovative at this point, right? Everybody should have it, but it's certainly a cost-effective lighting from an operational standpoint. For generation, they had 7.7 kilowatts of solar, again, to get to that -7. For quality, they had planning meetings with all of their subs to make sure that everyone was on the same page with what they were trying to do. Comprehensive water management for durability so that the walls wouldn't get wet and deteriorate. And then in addition to that balanced ventilation system, they also added advanced filtration and controlled their sources of pollutants in the house. So pretty good package for what ended up being an affordable home. And if you look at this, there's nothing particularly incredible here, right? Open cell spray foam widely available with zip sheathing on the outside, blown-in cellulose in the attic. Nothing fancy there. Triple pane windows is probably one of their big investments. Ductless mini splits is more on the innovative side, but they've made it cost effective by having fewer heads using transfer fans to circulate the air. The next example I want to show you is this above garage ADU. This is out in Washington, I believe, where they've got a detached garage on the property, and so they built this ADU to help the homeowners with rental income, and we're also able to use the ADU's roof area for solar that helps to power both the accessory dwelling unit and the house itself. So good use of space in this situation. Again, nothing fancy on the walls, blown in fiberglass, as well as continuous insulation to get to a total of an R31 wall. They are using an unvented attic with above deck insulation. That's not really common in residential construction, so that's a little bit out there, as well as blown in at the ridge line of the roof. Floor insulation, because it's a ADU over a garage, they had to insulate that floor. They have R48 blown in. Again, it's a lot of insulation, but it's not a particularly innovative type of insulation. So you can see kind of how some of these builders are trading off amount of insulation for maybe some of the cheaper kinds of insulation. Triple pane windows, again, that's a big investment here. And then Aero Barrier got this down to a 0.94 ACH 50. And that's really impressive given the fact that this is first of all, it's above the garage. So there's an external floor here, which has to have extra attention to detail. And then also it's a small volume, which is harder to hit that 0.94 ACH 50 on the small volume. For conditioning, one of the ways they saved money was they combined their ventilation system with their heating and cooling. So they used a conditioning ERV, kind of a niche product, but for a small space like this, it works really well. And then they can get, again, one of those products that does multiple things, heating, cooling, and ventilation. Heat pump water heater, and then also they used lighting controls along with their LED lighting. The rooftop solar was 5.85 kilowatts, probably more than just the ADU alone needed. The ADU was actually a HERS negative 20, but again, they were able to use some of that excess production to help power the main house. Comprehensive moisture management for their durability, indoor air quality, had that CERV, as well as advanced filtration and pollutant source control. They had an interesting thing with cork flooring and recycled countertops, because one of their goals, they would say that a zero energy ready home has to have sustainable materials, or zero energy home, excuse me. So for this builder, part of defining cost effective was including sustainable materials. And so that was something where they had to think about their product selection. The next project I want to talk about was really an impressive project in my mind. It's a mixed-use multifamily building where the first floor is retail. And then I think it's maybe 39 or 40 units. It might be 60. I'm forgetting the exact number of apartments. It's net zero performance on a whole building basis. You can see all of the solar there on the roof, but there's some really incredible things about this design. One is that, first of all, it's ICF construction for multifamily, which I think is a great application. It also has a ground source heat pump system that serves for both the heating, cooling, and also the mechanical. And what's amazing about this is that when the designer was asking the ground source heat pump contractor for a quote, the contractor said, "Do you want hot water with it or not? It doesn't cost anymore." And that's really incredible that they can get their heating, cooling, and hot water for the same price as their heating and cooling. And the reason for that is, for the ground source heat pump, of course, you want to be grabbing waste heat in cooling mode whenever you can. This apartment building, despite being in upstate New York, is actually cooling dominated because it's so super insulated. There's hardly any heating load. Most of the load in the house is actually in the units is actually from internal gains. So they're able to operate the domestic hot water without upsizing the loop. They didn't have to do any more drilling for that. Another interesting aspect of this is that the drilling is actually under the foundation, so that they didn't need any extra space to do it. ICF walls is pretty innovative. This builder has argued to me that when you want to get to zero energy, cost effectiveness around ICF starts to look a lot better because it's harder to get super insulated and lower HERS scores with traditional products. And it allows them to do it with or you need much more attention to detail with traditional products than they're able to use with the ICF, which is very easy to install and to air seal. For the roof, they use closed cell spray foam, ICF basement, as well as under slab insulation, and then triple pane windows. Of course, that's another advanced product, but they're finding a way to make it work in multifamily building. 1.9 ACH 50 for this builder, that's actually pretty high. Their single family homes are down closer to almost no leakage in real measured amounts, but multifamily is a little harder to seal. Again, that ground source heat pump is what I think is really innovative about this project. They're also using energy recovery ventilators for all of their indwelling unit ventilation and CO2 sensor controls for boost ventilation. The solar, they had 248 kilowatts of solar, and got to a negative 14. I guess that must be a per unit number for the HERS index itself. For quality installation, they had an integrated design process where they worked hand in hand with their energy consultant, met with subs, and I've heard the project managers on this say they really had to bring the GC along to understand this different kind of construction and have a lot of input in that kind of quality installation process. Durability, they have high wind resistance in this project. And then they have advanced filtration and pollutant source control in addition to that sensor-controlled balanced ventilation. Have about 19 minutes left here. This is an interesting project I want to highlight real quickly. It's in Arizona, and it's grid interactive energy performance at a production scale. What I think is interesting about this, again, there's not anything super, I don't know, kind of out there as far as how they're building. Open cell spray foam, very common in the Southwest, along with some rigid foam insulation on the outside, open cell spray foam in the attic, and they're using double pane windows, but they're getting to a 0.66 ACH50 on a production scale, which is pretty amazing. Again, using this aerosolized air sealing product. This particular builder learned how to do it themselves, and so that's how they made it cost effective. So they had their staff trained to install the aero barrier system, and they do it on all their homes. That's how they can save a little bit of money. But I can't stress enough, at a production level, the predictability of air sealing results has a cost factor to it, right? If I can say that every time I'm going to meet my air sealing target, I'm not going to have to go back out on site. Every time costs money. Re-air seal things, find the leak, do infrared testing to find where my leakage problem is on something that fails. This is really key to a builder doing volume, especially if it fits their building type. Mechanicals, again, nothing super fancy here. They've got a central air source heat pump, an efficient one, but it's just a standard split system heat pump. Energy recovery ventilator with IAQ sensor controls. We're seeing a lot more of this now. Builders are thinking about ways that they can optimize their ventilation system size by controlling it based on actual pollutant load in the space. And then LED lighting and lighting controls.
So Joe, that IAQ sensor would just be like a humidity sensor, a CO2 sensor, some of those things.
In this case, it's a CO2 sensor. Other people are using PM sensors. You know, the main thing we actually are concerned about in indoor environments, as far as long-term effects on human health, is particulate matter generated in cooking, and then NO2 generated in cooking. Yeah. Those are kind of the acute things, and formaldehyde's a little bit expensive to do sensor work on. CO2 is kind of a proxy, right? We know that people are breathing in the space, and so we want to ventilate it at those times as opposed to times when nobody's there. But yes, you could do humidity sensors as well. There's a lot of different ways. This particular one, I think, was CO2.
Great, thank you.
Yeah. The other really interesting thing about this project, and this builder in general, is that they've done a lot of work optimizing their solar system combined with battery storage. So you see they've only got 3.75 kilowatts, and they're reaching a HERS 14, and they would say they're actually reaching zero energy performance, and it's not quite captured in the HERS rating system yet. But how they're doing that is they've done studies, and they're using controls to optimize when the solar is being used and when the battery is being used. And they're analyzing local time of use rates, which they have for residential construction, and actually advising their customers on which utility plans to use based on their algorithm for optimization use. So they're able to get to actual zero energy performance regardless of the HERS index
Mm.
with a smaller solar system by optimizing that battery system and
So,
the controls around it. Go ahead.
so Joe, they're in a market where there's a peak off-peak rate that they're really
Yes,
trying to plug into and optimize.
that's right.
Got it.
And so in an area where you don't have that, in an area where you don't have residential time of use rates, or you don't have net metering, this is a little bit more complicated. But
Yeah.
if this fits your situation, they're able to buy a much smaller solar system and pair it with the battery than they would have to. I think they said this would need to be like a 7 kW system if they wanted to get to actual zero performance. Otherwise, and you still wouldn't get quite to zero performance because of, the peak and non-peak aspects of it.
Right.
Yeah. And then this builder also uses BIM modeling. Another thing that I would stress is important. If I can limit the amount of waste through digital modeling of my construction practices, I can make it much more efficient. A lot of times we talk about cost effectiveness as if it's like, I put this widget in and it costs X dollars and I save X amount of energy. But a lot of the cost savings are outside of the energy realm that we can find. And efficiency in how we're building and efficiency in design can really be a great cost saver and allow us to do more on the energy saving side of things. And like I said, training their in-house trades to do aero barrier instead of going out to a external contractor allow this builder to do it much more cost effectively. This example, I just want to highlight. We have about 13 minutes left, real briefly, because it's a SIPS home. And one thing I want to stress about this product is, first of all, it's one of those products that I mentioned before that does multiple things, right? This product is my whole wall. So it's everything structural and my insulation, my sheathing, my air sealing. It's all in one package, really. And so I love products that do those multiple things. The other thing about this is the flexibility. Like the idea that if I've got a SIP panel, I can put a window anywhere, right? Because of the way the system works. If I need to change my design midstream, I've got some flexibility to be able to do that. Not unlimited flexibility, but there is some amount of flexibility I have as I'm installing these panels to change my egress points or things like that. So I like that about SIPs. This particular house used an R29 panel and an R49 panel on the roof. ICF basement. I don't actually see a basement in there, so I'm not sure if that's a misprint or not, but maybe there's part of it that's in a basement. A 0.15 or 0.18 triple pane window, so that's pretty advanced. And then they did add aero barrier in addition to the SIPs. But look how tight they're getting, 0.47 ACH 50. I'm not sure they needed both SIPs with joints taped and aero barrier, but they wanted to get to super tight and they got there. An air to water heat pump, again, one of these products that's doing multiple things because it's doing their heating, cooling, and water heating. Unlike the ground source that we showed before, it's an air source heat pump, and it's being used to heat, cool, and water heat the space. And then finally, heat recovery ventilator with more of those CO2 sensor controls. This builder is also using or trying out the particulate matter sensors as well. And then rooftop solar, they're using 12.87 kW, and they're overproducing -22, but they're using that to charge their electric vehicles. So one of the ways to do electric vehicles cost effectively is you've got to have solar, and it's helpful to have a battery there as well. This is only battery ready, but I
Joe,
think that's important.
Joe, have you seen any of the Tour of Zero or Housing Innovation Award applications doing vehicle to grid or integrated charging yet, or is that coming online?
I've seen people talk about it.
Yeah.
And I'm not an expert on this, so if somebody's on from vehicle to grid company, that makes a product, I'm not trying to say anything specific about your product, but I would say that the reviews I've heard so far is that there's some software work still to be done. From people who have bought two-way chargers, kind of, or bi-directional chargers, excuse me. I think that that's an incredible potential. And I'm sure some people have found ways to work, but I've also heard a lot of hiccups. So it's one of those things that's kind of getting out into
Well,
the marketplace, and I'm sure it'll continue to improve.
it'll
You
be
had something else?
interesting. It'll be interesting to see because you've got the application period for next year's awards are coming up, and if
Yes.
that's a big shift that we see in a new technology coming
Yes.
online.
Yeah, I'm always interested in seeing those. I'm not seeing a ton of them yet, in at least in the Housing Innovation Awards and Tour of Zero, but I am seeing some of the builders talk about the concept, but actually putting it in, not quite.
Great.
I have about 9 minutes left here, so I'll talk about a couple final projects here. This one in Asheville, North Carolina, it's a I don't think they describe themselves as modular. It's factory built. So they're a panelizer, but they kind of have set designs for their houses, and they're achieving cost effectiveness through this kind of factory environment. We have again nothing earth shattering as far as the wall, blown in cellulose and rigid insulation, along with open cell spray foam at the roof deck. Slab edge insulation, that's pretty typical. Double pane windows, and for their air sealing, they're using strategic use of spray foam as well as gaskets. So nothing real earth shattering there either. But they're getting to that zero energy performance through a careful attention to detail. Ducted heat pump, again, kind of central split system, along with maximizing passive solar design, heat pump water heater, supply side ventilating dehumidifier, which they found worked better in their climate than a balanced system. And there's some builders who feel that way in the Southeast. And then for solar, they've got 7.2 kilowatts on the roof. Negative 21 ERI. Again, this is an example, I think, of a right-sized home. They've sized the home so that they can overproduce and have the potential to charge an EV system. So they focused on getting the system pretty efficient, efficient mechanicals, oversizing that solar a little bit, and then hopefully that'll be a long-term cost effectiveness for the home buyer. The factory controlled environment, again, adds some cost savings for this builder. And they have very high termite, hurricane, and wind resistance built into all of their structures. So this builder focuses on delivering long-term durability so that the buyer can realize those cost investments that they make up front. And now I'll show this home from a builder in Virginia who likes to use the term simplicity of the build. One of their big focuses is not doing things too complicated, trying to keep things as simple as possible because they know they can replicate it and they know they can achieve it with a high amount of quality. So the type of systems they're using, flash and back cavity insulation with continuous rigid insulation. Again, nothing kind of out there as far as their walls, blown in cellulose in the attic. This builder, by the way, is upgrading as they move to the Zero Energy Ready Home version 2, all of these insulation things to meet the new specification. But at the time this home was built, this was, what they needed to do. Rigid foam insulation in the basement or crawl space, depending on what they're using in that development. And a double pane window, pretty standard stuff that anybody can get on the market. They're getting to a 1.4 ACH 50 essentially through attention to detail. Mm-hmm. Their products help them. Open cell in the wall helps them some. Tape on the zip board helps them some, but mostly it's attention to detail, and I think that's an important aspect of this design. A ducted heat pump, again, just a regular split system heat pump along with a heat pump water heater, energy recovery ventilator, and LED lighting. They've got 6.2 kilowatts on the roof and are getting to a HERS 4 on this particular home. They have EV charging and battery options. so the homeowners can get that. But one area where this builder really stands out is in BIM modeling. In their design meetings, they're identifying every screw, every inch of siding that they're going to need to order, every stud, every floorboard. They have it counted exactly. So they don't have waste, or at least very limited waste in the home, because their BIM modeling is so sophisticated that they can predict what they're going to need and not have to overorder. There's a huge cost savings in that. The other thing that I want to mention about this builder is that as they thought about community solar, it may not be the most cost-effective solution to put rooftop solar on every house. In fact, as a society, having each of our homes be mini power plants might not be the most cost-effective way to get to a societal zero energy. It certainly has its place, and I love rooftop solar, but it might not always be the right fit. So one thing they're planning in one of their next communities is community solar. And the thing I want to stress here is that utility rules can make a big difference on whether this is cost effective or not.
Yeah.
So, for example, one of the roadblocks they ran up against was the utility wanted to, for any community solar system, not rooftop solar, but community solar, they wanted to charge a $75 minimum bill. And the problem with making it a minimum bill is that you've now disincentivized the builder from going from a HERS 40 or HERS 0. Because if I add all that cost to get to zero, that HERS 40 home might have a $150 a month bill as it is. So if I go all the way to zero, I'm now only getting $75 of that $150. So I've wasted half of that investment there. If it were a fee, that's different, because I pay my fee and then I pay my usage on top of that, and there's still motivation to get from a HERS 40 to a zero. But if it's a minimum bill, that structure disincentivizes going to zero if I'm already at efficient construction. And I think we're almost coming up on time here. Any last questions?
No, I think if you want to keep going through analysis tools, let's just keep driving on, because we could do a whole hour talk on this, the differences. Like, I thought it was interesting on the multifamily project. I mean, they interconnected 248 kilowatts of solar, but I think, at least where I live in Minnesota, we're limited to a 40 kilowatt interconnect per address.
Yeah, absolutely.
So it's all over the board out there. But I love what you're talking about in energy rating software, because this is really what makes it all come together. Because I think we saw in your examples a lot of different approaches: this type of wall, this type of roof, this type of basement, this type of air sealing. This is where it comes together in the energy rating software. So if you could touch on that briefly, that'd be great.
Yeah, and this is just a highlight. I can't teach anybody how to use all of these in this time frame, but there's a lot of tools out there, and they all have different benefits to them. Something like NREL Open Studio ERI is meant to be kind of this open source engine. Woofy has a lot of moisture modeling that goes into it. BOPT has optimization of, you can optimize dollar per HERS score kind of things. There's all these energy rating things that are really helpful. One thing, if you're a builder and you're working with an energy rater, some energy raters out there are the best people I know in the business, and they will help you get to the best, most cost-effective solution for zero. Sometimes you're going to be working with a rater who says, here's how I've done it in the past, that's how you get to zero. There's no one way. And so if you're not getting an answer in the energy model that is cost effective for you, you're going to need to redesign, and you may need to pull the rater along with that. Again, a lot of raters are great and they'll work with you on it. Sometimes you're going to find you have to pull your rater along. And if that's the case, sometimes it's worth it to get the HERS rater training, just so you know what you're talking about when you're talking with your energy rater, and say, no, I think if we change this, we can actually get the same R value, but at a lower cost with this product. And it's just something to keep in mind that there's a lot of optimization that can happen here. There's never one answer. And if somebody's telling you there's one answer for how to get there using these softwares, it's because they want to give you a package that's already set. They don't have to do anything.
Yeah.
So
Joe,
something to keep in mind there.
Can you just briefly discuss, I know we've had past discussions on the energy rating software that is ready for 2021 IECC and Zero Energy Ready Home version 2. Can you, without...
Yeah, Ecotrope has been approved for, I can't really talk to 2021 IECC. I know Ecotrope has that. The others, I think Energy Gauge also has that, and House Rater. I don't know about REMRate. They may have 21. But as far as the products that have been submitted to the Zero Energy Ready Home team at DOE for approval for Zero Energy Ready Home version 2, Ecotrope is passed. I believe Energy Gauge is close or approved. I'd have to double check, actually. My software team is not here at the moment, or I'd shout across the room and confirm about Energy Gauge. So my apologies to anybody at FSEC if we have finished that. But that should be any time now. So Ecotrope definitely is approved, and Energy Gauge should be shortly. So those are, and then in California, of course, it's Title 24 software. It's a one little difference if you're in California.
Yeah.
And I think that's all we've got time for.
Great. If there are any questions to wrap up here, we'll sure take those now. If not, and we'll give you a chance. Joe, incredible presentation as always. Thank you so much for bringing your knowledge and sharing with our community. And it's always great to have you here. So I don't see
here, Aaron.
Yeah, I don't see any questions coming in. So with that, we'll look forward to seeing everybody at our next session.
All right. Thanks a lot, Aaron. Take care.
Thanks so much, everyone.